Good morning, class. Okay, today we're going to go over the procedures on how to do lab 5, which corresponds with chapter 4 on the binomial and Poisson distributions. Now, the first question here asks us to set up this table, and then you get these values here from the table in the back of your book, the binomial table in the back of your book. So let's open up Minitab, and we're putting in the values. I'm going to call this column X, and we're putting in 0 through 4. So I'm going to show you, if we're just doing these, I can do 0, enter 1, enter 2, enter 3, enter 4, enter. And this one's going to be called probability of X, and I'm going to show you how to set that up. So we're going to go to Calc, Probability Distributions, Binomial. These are probabilities, so be sure, remember that when it says in the lecture on chapter 4, I mentioned that you click this button, probability, if you're looking for the probability that X equals a number. Cumulative is for if probability of X is less than or equal to some number, and you're not going to be using inverse cumulative probability in this course at all. Now, because the highest value that we want n to be in this case is 4, we're going to enter in 4, and it says in this problem that p is 0.05. It says that on the lab, and we're going to input the column this time because our data values are here in this column, and I input the column, and I'm going to store in C2. Okay, so see what we've done? Probability, to set up these tables, probability, n is 4, so in the problem on the lab, let me show it to you. Okay, see, n is 4, probability is 0.05, right? So now we put the values 0 to 4 into C1, and that's my input column, and my storage for the answers is going to be C2, which I have labeled P of X because it's going to be my probabilities of X. And there they are. Just copy these onto the lab. And the next column on the lab here, you just get these values from the table in the back of the book. And by comparing the above results, what advantage does Minitab have over the table? Well, I think one of the biggest things we're going to see is that it is more accurate. Now, to do these here, let's look at problem 3. If n is 100 and p is 0.5, let's find the probability that X is 35, 45, or 50. Okay, so now my values are X from number 3 is 35, 45, and 50. And I'm going to put P of X3. I'm going to call this column P of X3. And we go to Calc, Probability Distributions, Binomial. And this time, my C3 is X3 and C4 is my optional storage. But this time, n is, you read in the, let me show you. You read in the problem that n is 100 and p is 0.5. So let's make those changes. N in this case is 100 and p is 0.5. Click OK, and there's the answers. Just copy them onto your lab. So that was number 3. Now number 4 is the same, except we're changing the probability now to instead of 0.5, we're changing it to 0.4879. Cumulative probabilities, I do want to go over cumulative probabilities with you just a little bit. To do cumulative probabilities, that's when we're looking for the probability that X is less than or equal to a value. So for the first one, we're trying to find the probability for the girl, so we're going to change the probability in the problem to 0.4879, and n is going to be 100. But fewer than 60 does not include 60. That means we're looking for the probability that X is less than or equal to 59. So to do this, I go to Calc, probability distributions, binomial. Now I'm looking for a cumulative probability, so I'm going to change that to cumulative. I need to change this to 0.4879. And now I'm putting input constant. I'm doing the input constant because I'm only putting in one value at a time. So the value I'm putting in for the first time, remember the probability, let me change it back up here, the probability that x is fewer than 60 is the same thing as the probability is less than or equal to 59. So I'm going to put in here 59, and that's the answer. That's the correct answer. Part B is the same as part A, right? Except we're changing it to, instead of fewer than 48, means less than or equal to 47. But at most 30 does include the 30. So in that case, I'm going to change it to calc, probability distributions, and binomial. But this time, I leave it 30. I don't change it to 29 because at most 30 does include 30. And that's the answer. All right. Next, at least 55 means greater. At least 55 means greater than or equal to 55. In the lecture on the chapter, on chapter 4, I discussed this and told you that if you're doing greater than or equal to, that's the same thing as 1 minus the probability that x is less than or equal to 1 less than 55, which is 54. So I'm going to go calc, probability distributions, binomial, 54. So the probability that x is less than or equal to 54 is 0.8734, which means the probability that x is greater than or equal to 55 is 1 minus 0.8734. Okay, so, and then that's the answer. You put that into the Minitab. All right, so the next thing we're going to be looking at is the rest of these should be fairly similar. These are all binomial until we get to number 14. Number 14 is using the Poisson distribution, and so is 15. Okay, so we need to look at the Poisson distribution, and the first thing we need to do is look at the, hang on just a second. We need to look at finding the mean. Okay, so we'll stop for, I'm going to pause for just a second, and then we're going to work on Poisson. Okay, so now we're going to look at the Poisson distribution. This problem here, this example here, was one of the ones on the PowerPoint slides on chapter 4. So I want to remind you how we do this. We're trying to find the mean number of radioactive atoms lost through decay. So if we started off with 1 million and then we ended up with 977,287, then the number that was lost was 1 million minus 977,287, which is 22,713. So now we're going to go to calc, probability distributions, and Poisson. In here, they're asking me for the mean, so I want to put this in there, 22,713. And I need to either do probability hang on just a second. Oh, and that's got to be, that is divided by the number of days in a year, because I want the mean number per day. So divided by 365 is 62.23. Okay, so I go back up here to Poisson, and I go to calc, probability distributions, Poisson. The mean is 62.23. And I'm looking for the probability that x is equal to 50. So my input constant is 50. Not column, and we only use the column whenever we have multiple entries. But since it's equal to, remember, probability stands for equal to, cumulative probability stands for less than or equal to. So click OK, and the answer is 0.0155, or about 1.55% probability that on any given day, exactly 50 radioactive atoms decayed. Okay, so I think you should be able to finish the rest of the lab. If you have any questions, please email me and we can talk about any questions you have. And I want you then to make sure that you do finish this lab, get it up, scan it as a PDF, upload it to the portal by the due date, and make sure you have done the homework for Chapter 4. After this, the next big assignment is your midterm. So remember to your midterm covers chapters 1 through 4. If you have any questions on the midterm, you can find the due dates for the midterm on the portal also. The midterm is open for several days, so you have your choice of several days on which to take the midterm. If you have any questions whatsoever, do not hesitate to email me.